Thank you so much for the opportunity given me. Today, I want to present the Pavement Maintenance Management Program. 2 weeks ago, Engineer Achu set the tone for the historical background about the road condition survey, and for that matter, the Pavement Maintenance Management Program. So having known or having heard of the historical background, I want us to quickly go through the details of it and see what it has in store for us. So in my presentation outline, I'll try to define the PMMP. You look at the overview of the maintenance management program architecture. You look at basic data requirements, how to partition the network, how to conduct road condition survey. You look at reports and the outlook of trunk roads in Ghana over the years. Then you look at road fund budget to GHA for maintenance budgets over the year. Then you will also look at the effects of funding gaps on trunk road maintenance in Ghana. Then I'll talk of the challenges. Then I'll also talk of the way forward. Thank you. Please join with me as we go through the presentation. The PMMP, as we know, is an expert tool that assists decision makers in finding optimum strategies for planning and budgeting of roadworks. So the key emphasis here is for planning and for budgeting of maintenance projects. It's a computerized based program. It sits at the head office with the programs manager. So it's part of the road maintenance system architecture of the institution. The PMMP stores data, and these data, they are the road inventory, the condition survey, the roughness, and traffic data. Okay, so what does it do? The PMMP, what does it do? Okay, it's for the storage of road condition survey and analysis, budget preparation, and it is also interface with the ArcView GIS and the HDM4. So on my view, on my screen is what you have, the system architecture. So we have the road condition survey, the traffic data, the roughness, all going to the PMMP software for analysis, and it's being interfaced with the HDM4 and the ArcView GIS. So this is a typical road condition survey data from the field. Okay, so this is a typical, so this is the road. If I talk of road condition survey data, this is what I mean. This is the sheet and the forms. We'll talk about it later, how to get these entries. Then also traffic data in a standardized way. We are aware of this sheet or this forms for a standard form for collecting traffic. It's what it goes into the PMMP. Then also roughness is being conducted and it sits at our materials division. We have a roughometer that they use to take roughness on our trunk roads and bring the results for input into the software for analysis. So when the software do the analysis, the road inventory, the defects, the international roughness, the condition are all put together, and we have a complete database for maintenance works program and ongoing product and budgetary allocation. Now, the Ministry of Roads and Highways developed what we call a DDT, a data transfer tool that is able to help us export the output of the HDM4 of the road condition survey into the HDM4 for economic analysis. So, for example, this is a typical analysis from the HDM4 that the system gives us. For example, if you want to upgrade or change a gravel road to a bituminous road, the system is able to help us have alternatives and for different scenarios when traffic growth increases. We are able to know it and see and analyze the internal rate of returns, the net present value, and all these economic indicators to help us make an informed decision as to whether the road is viable for construction. So the HDM4 is there as an appendix to the road condition survey or the PMMP. Then We also have the ArcView GIS. This is a thematic map of functional class that was conducted or taken at Ghana Highway Authority with a view to interfacing it with the HDM4 or the PMMP. So this is an in-house built functional class network map so that you can be able to view thematic map, traffic map, functional classification maps of the network when it comes to the HDM for administration of the project or maintenance project. So this is just the flow of information or data from our head office is being collected at the field as we have over here. Then it is being processed and sent to inputted into the data and retrieved and sent to head office for analysis. So this is how it flows. It flows, the data flows from here, from the regional level to the national level for analysis. So the information is being collected by the road area managers on the field, then they are being sent to the head office so that the head office programs manager collate all these together and run the analysis, input them in analysis. So it calculates what we call a condition score. This helps us to prioritize roads. Remember I said it's a decision supporting tool to prioritize road for preparation of budgets too. So either a technical budget or an expert or edited budget, which I'll talk briefly. So let's talk about data requirement. Now, the regions have been partitioned, and the natural partition of the regions are the regional boundaries. So we have what we call, we establish what we call a local referencing system. These are permanent position or posts like bridges, like regional boundaries, rivers, and these indicate where a region ends. And that is the first call of our local referencing system for each partition of each region. Now, the road is divided into homogeneous sections and subsections because we are going to collect data. So a dual carriage and a single lane carriage cannot have the same data collection or data. So we try to fragment the whole entire network into homogeneous uniform sessions and subsessions, and data is being collected on these homogeneous sections and subsections so that we can have informed data to input into the software. Then after we've been able to partition or fragment the network, we have to give what we call a unique coding and identification and numbering system, so that as soon as I mention that code, you will know that section that I'm talking about. And we can also assign that attribute or data picked from the ground to that data. So we do this data collection in a standardized manner, like I showed you the standard data for a standard sheet for carrying out traffic data collection. For example, this is the 9 categories of traffic. I showed you the sheet for collecting data worldwide. That is how it is being collected. So data has been collected in a standardized manner. Another call for partition is the pavement surfaces. So we have the paved and unpaved road. For the unpaved road, we have the bituminous and rigid. And for the paved roads, we have the bituminous and rigid. Then for unpaved road, we have the gravel and on the earth and the earth. For the paved road, we can also have the bituminous, that's the surface treated, the asphalt. Rigid, we have the Portland or the brick. So another call for partitioning is the functional class. National roads from the national capital Accra to the regional capitals, the interregion for interregional coherence, and the region is between the districts. So there's divisions of these subsections and subsections I was talking about is the
recording in progress.
So this is the post that we have at the boundary between Western North region of formerly Western region and Ashanti region. So this is one of the, what we call the referencing system or the post that will show you that when you get here, this road section or segment has ended and that the next region continues. So these are there. They have been so many years in the system, but they have been vandalized. But this is just to show you one of the local referencing systems that we have for highways. So then we have what we call links and nodes. The distance between two national routes is a link, and any two termini or node, any other road, highway road joining that link is a section. So before partitioning the network is being divided. The map scale is 1:100,000. Then you section them accordingly into the uniform section and subsections according to the cross section, the pavement structure, the environment. Okay, there's a caveat that the section should not be less than 0.5 of a kilometer. It should not be more than 5 kilometers. This is just to help you in the ease in data collection. We also can collect accident data and traffic data on these same sections and subsections. Sections can be merged when they have been worked on or we have applied intervention and they are now uniform. You can now merge them. The system allows you to do that. So the referencing sections give you what we call the route number, the link number, and the actual sequence of the chasing that occurs. So this is what we have. So for example, after I have finished partitioning, if the functional class is a national route, it's N, the route number will be 1, the link number maybe is the first link I'm talking about, maybe it's the second section, the 5th section I'm talking about, and the road number now becomes N10105. So this N10505 means that National Route 1, Link 1, Section 5. So this is what you use for interregional routes. Let's say route number 4 is the same, maybe IR4, which is for the functional class. 07 is the link number, and 02 means I'm talking about the second section. So this is what we do, and you fragment them as of the entire network. So the objective of the road condition survey is to assess critical areas that need future intervention, to determine severely damaged areas that need immediate intervention, then also to give an estimate quantities for award of tender and to identify the pavement condition drainage that we have on that section. So it's a network level survey. Normally we conduct this survey road condition in May, June before the onset of the rainfall. When we have the project level survey, we do the HDM4, it's shifted to the HDM4 to do the in-depth analysis of the economic viability, and the regions are assigned to do the detailed work as the DCP and any other thing to determine the pavement thickness and everything for that section to be worked on. So roughness, also we have the roughness, we have a roughometer. This is seated at the materials division at Accra North, and they also go out to take roughness on these entire roads and give us the results for the input into the PMMP. So prior to their going, we give them these same sections, then they'll use that one to do the same data collection. So we have the roughometer, and this is just a simple equation that tells you, and it tells you that if roughness is this, it means it's good between 1.5 to 4, and it's fair between that 4 to 7, and if it's greater than 7, then it's poor. So the visual road condition survey, we want to determine the severity and extent of pavement on gravel roads and other flexible roads. So we do that to assess the condition of road appurtenances like the shoulders, the culverts, the drains, and other things, their condition. Then also it assists decision makers in finding remedial measures for required work to be done. So the survey is conducted annually, okay, and the preliminary budget is done, and we go to the field. So when we are going to the field, the trainers or the raters, Normally the road area managers are being trained. We do a retraining for them to refresh their minds. The idea is to reduce subjectivity so that they can take it in a very objective manner as the standard of collection of the data. So we allocate logistics and we plan the calendar. So when we are going, the PMMP software has what we call the virtual memory. And this memory has the listings of all the roads that is in Ghana or of trunk roads. So we give out to them area by area or region by region, and they take this. They already have this information and they go to the field. So when they go to the field, the sectional listing notebook has what we call the road name, the road number, the section number, road from which town to another town, kilometer from, kilometer to, so you not miss the section that you want to take. Gives you the length, the surface type, then you have it. Number of lanes, they are all there in the sectional listing notebook. So we print it and we give it to them, and that's what they use to take out for the data collection. They cover at least 100 kilometers in a day, and they do it in a loop form so that they can start from one end and come back to their previous destination. So 2 persons and a driver are qualified for road condition survey, and they do it in what we call the windshield survey by driving 20 kilometers to 30 kilometers per hour and observing the distresses on our roads. So in a manner, we plan the road condition survey in a manner that, and we assign items to the data. So the field assignment is what we do, and they take the sectional listing notebook. So like I've talked of the windshield survey, and they use the odometer for the survey. So the equipment they take or the logistics they take is that they have the manual with them. If they want to refer to anything, they can easily refer. They have these blank coding forms for the forms, standard forms for data collection. The listing notebook, which I have talked about, they have the roadmap to guide them, a clipboard and a folder also to go. So you have pencils, eraser, and other things, and a hard cap to protect them from the hat. They also have cameras to take pictures and show us. So the forms are in 3 forms. We have the RCSP1, which is for the condition. They have the RCSP2 for the appurtenances, that's the shoulders and other areas, and we have for that one for the gravel. How do we ensure quality assurance on, when taking the road condition survey? Okay, quality assurance is assured through the training of these raters to recognize distresses and fill them in a consistent way. Also to reduce the reduce of subjectivity and to assure uniformity in data collection. So when they are doing this condition survey, an experienced rater will go and join them from the head office. Usually will move from one region and join them, and he will do what we call, he will go and resurvey some of the sections and give them feedback comments on these sections. So we obtain data and survey and obtain samples for re-rating, verify sample ratings, and develop summaries and get feedback to them as to how they can polish or fine-tune their expertise in the data collection. So these are the rateable distresses. We rate distresses according to the severity and the extent. So we have what we call the localized, when the coverage is between 1 to 15, the intermittent between 15 to 30, and prevalent when it's greater than 30. And it is slight, that is for the extent. And it is when for the slight, you look at how to rate one of the distresses, then you know how to know whether it is slight, moderate, or extreme. So we choose a road that is a matrix. If it is localized and it is slight, you choose one. That's why we have this. If it's localized and it is moderate, you choose 2. And if it is extreme and localized, you choose 4. Similar with when it is intermittent and when it is prevalent. Okay, so these are the ways. So let's see how you rate one of the distresses. So rateable distresses of surface treated road. Let's see just one, how to rate one of the distresses. So common distresses on flexible pavements are the alligator crackings or fishnet crackings, the depressions. We have rattings, we have raveling, we have transverse cracking, longitudinal cracking, edge breaking, lane or shoulder and patching. Now, the extent I've already talking about, the coverage or the section, because we've already fragmented your network into sections and subsections. So these sections is what you are dealing with. So if the coverage percentage-wise of the defects that you are talking of covers up to 15, then you know that it's localized. Then if it is between 16 to 30, then it's intermittent. And if it's greater than that, it's prevalent. So for alligator cracks, we are looking at the crack width. If the crack width is greater than, is less than 6 millimeters, then it means it's slight. If it is between 6 to 12 millimeters width, then it is moderate. And if it is greater than 12 millimeters, then it is extreme. So how do you know with your eyes that it is fine or it's wide? You sharpen your pen to a pencil tip, the pencil to be pointed, then you dip it into the crack. If the graphite writing point is entering, then it means that it is only entering, then it means that the width is between 6 and that is slight. If it is the wooden sharpened end, the cut end of the pencil at the tip is entering, then it means that it is assumed that it is millimeter, the millimeter is between 6 to 12. And if the whole pencil is entering into the crack, then it means that it is wide or it is greater than 12 mm. So you are in the extreme column, then you choose the matrix. So a similar, this just the alligator cracks I just want to talk about. We also have depressions. Depressions are a similar type of ratting, but this time around, it runs parallel to the moving vehicle or the profile of the road. So we also have it, you put a crossbar across the depressed area and measure the depressed depth. Then if it's less than 20 millimeters depth, it's assumed to be slight. If it is between 20 to 50, it's assumed to be moderate. And that then you establish the coverage. If the coverage is what I have said, up to 15, then it's localized. Then you choose the appropriate matrix that we have and slot it into the forms. So these are that. So the system uses what we call dictate values. Whatever value you pick for the 9-box matrix of 1 to 9, whatever you pick as your rating, the software picks what we call dictate values. And these dictate values are picked and they are used to accumulate. You add them together, you subtract them from 100, and that becomes the condition score of the road. For example, this is a typical, the dictate values are encoded, but they are weighted values based on what you pick. So this is a typical example of dictate values that we have for, this is what is in the virtual systems, virtual memory. For example, ratting, 1, 2, 3, 4, 5, 6. These are the dictate values. So when you superimpose the 1 to 9 on this sheet, for example, if you pick 9 for severe and prevalent, then it will pick what we call 5. It will pick the number 5. It will pick 5 to enter a pick as the dictate value and calculate the score. So the system will, if you rated alligator cracks, depressions, rattings on the entire section, it will pick all these values, look for their dictate values, sum them together, and subtract them from 100. And then what will be left is the condition score. And these condition scores are now being rated as either good, fair, poor, or okay. So these are the pavement type, the condition score, and the score. So a score greater than 90 is assumed to be good. Fair is between greater than 70 is good. Fair is between 70 and 40, and poor for that is less than 40. And we have that for flexible roads, bituminous roads, and we also have for gravel roads. So after having had your scores of these various sections and subsections, these are the maintenance activities we apply or as interventions. Remember, I said the essence is to examine critical areas that need future overlay, and 2, severely damaged areas that need immediate intervention. So these are the interventions we apply. We either will be cutting grass, maintaining signs or guardrails, patching potholes, covers, edge break, crack sealing, or spots or grading. So these are the interventions we do for routine maintenance. For the periodic maintenance, either we'll be doing resealing, or we'll be doing or we're doing what we call rehabilitation, upgrading, reconstruction, or resoftening. So these are the interventions that we apply for periodic works. We also have emergency works, when there's a landslide, a collapse of a bridge or a culvert, or there's a washout. So this is the decision criteria. We have the condition score here, 0 to 100, at a neutral position where we have the fair. This is where the action decision point is taken, whether we have to apply any intervention. So at that, below this point, the user cost of the road becomes very high, and that it becomes expensive. Then also people begin to complain about the road when the condition score is below 50. So these are the criteria, the interventions that we have, the maintenance activities we apply. We have road maintenance activity, paved activities 1. So when the condition score is 100 to 90, we are only doing roadside maintenance, that is cutting grass, and when it is between 89 to 65, we will do what we were first doing. Then we will add shoulder maintenance, slide pothole patching, slide repair works of depressions and corrugations. So it moves on in that order. So as the road deteriorates or the condition score becomes lower, then you will still be cutting grass, but you will be applying more intervention like pothole patching, depressions, and go until such a time that you realize that it has come to resealing. You need to reseal the entire road when the condition score is between 34 to 15. So these are the maintenance activities we apply on the road based on the condition score from the road condition survey. So this also goes for gravel roads. These are the activities we apply on the road. So having known the unit cost of maintenance from our quantity surveyors, just multiply it by the total length and the budget is now ready for rolling. So we can either have an unconstrained budget or a constrained budget. Unconstrained budget is budget that we have enough money to fund the maintenance activities. Constrained is when we don't have enough budget. So we need to optimize it. We do this in 2 ways. We do it by either postponing some of the activities, or we, based on user-defined strategies for optimal budget constraints, we adjust the condition score, the criteria. Remember, I talked about this one. So now we are going to shift. It's like you have done an exams and you realize that most of your students did not pass. So now you want to bring the pass mark to say 40 instead of 50, so that a lot of students can go through the pass zone. So we adjust this table to make most of the road favorable into the pass zone. Then we get small nuts or small bad roads to deal with. So that is what we mean by user-defined strategies, by changing the boundaries of good roads and bad roads. So for the constraints, we just move the ladder from one point to another so that we can have less poor roads to deal with our budget. The system also allows us to rank roads based on the ADT, the average daily traffic that we have on the road, and the functional class. So we want to have, it's a decision tool. We want to know that which roads are most important to us for us to invest in. So it helps us to also rank these roads. And this is the criteria for the ranking road. The ranking is the class factor multiplied by ADT factor over the condition factor. The condition factors are here for national roads, for interregional roads, and for regional roads. So the economic decision tool is now then shifted to the HDM, for which I've talked about, that the ministry has developed a software called the data transfer tool, that you can shift the output of the HDM of the road conditions into the HDM for further analysis. Okay, so now I want us to look at the PMMP and the outlook of trunk roads in Ghana over the years. So when you look at this chart, it starts from, it's almost 3 decades now, the PMMP came into existence from 1997, rollout 1997, and now 2004, 29 years, 1995 to 2024. It's about 30 years now. Now, let's look at the performance of our trunk roads. We can see that this shows, the blue shows the good, the dark one shows the fair zone, and the poor zones are the yellowish type. So these are the performance of our trunk roads over the years that we want to turn. Now I want us to take a critical road. This is for paved, only paved roads. And this is for also for gravel roads. The good shows over the years how our trunk road has fared and over the years. And when you combine the gravel and the paved roads, this is what it shows. The blue shows the good of the paved and unpaved, the poor and the fair for the paved and for the unpaved. Now, I cannot talk about performance of our trunk roads without looking at budget. These are road fund releases from our road fund board. They have released to us to maintain the roads. Now, these from 2000 to 2024, these are the releases in millions. So you can have 15.1 million rising to a peak or a spike of 3,364.993 for this in 2016, and it has been dwindling over the years. So let's look at the performance of our trunk road vis-a-vis the releases of funds or budget from road fund. So you can see that increase in budget in 2016 to 364.93 million. In 2016, you see, what we have is that when you conduct a road condition survey for a particular year, in effect, you are examining the performance of the maintenance activities you rolled out in the previous year. For example, if I do a road condition survey for 2024, I'm looking at the performance of the network in 2023. So the activities or the maintenance activities that were done is what I'm trying to assess. So for example, in 2016, the budget rose to 364.93 million. That was a very significant jump of the network, of the money that was released. So when I conduct 2017 road condition survey, you realize that I have 54, which is good, and 35, which is fair. So when you add the two, you become the total motorable or good roads to try or move on to be 89. Then it dropped. The releases from road fund dropped from 364.39 in 2016 to 152 million in 2017. So when I conduct my road condition in 2018, I had 45% good and this 40% fair. When you add together, then it means 85. So it means you drop in your commitment of funds in road maintenance activities, you lose part of your network, or your network move from either a poor to fair zone, or a poor from fair zone to poor zone, or a good zone to fair zone. And the trend continues, a further drop in 2017 to 80 million in 2018. Our 2019 road condition survey also revealed 32 good and 49 fair. When you add together, you get 80%, 81% of our network being motorable. So it shows that there's a trend. And similarly, increase in budget from 2000 to 2008 showed also increase in condition survey from 50%, that's the total together, good fair, 50 to 53 to 59 to 70 in that sequence order. And again, when you increase from 2019 to 2016, when road fund releases increased, increase the road condition for good and the fair zone or the condition mix to 62, 79, 86, 91, 93 in that order. Yes, our untimely release of funds for annual road condition survey is one of the challenge. Lack of commitment to funding routine and periodic maintenance is also part of our challenge as a nation. The PMMP software is not now properly integrated or interfaced. So with the GIS and interfaces, some things we should look out for. Then challenges, partitioning of the network. Now the regions have increased from 10 to 16. So we need to repartition this network and fragment them into the system. Then also there should be an administrative control at the head office for the programs manager to be able to change the network. Now there are a lot of multiple lanes. Now you are developing the motorway into 6 lanes. We should be able to integrate it. That is not what we have here. Then some missing links in our network that has been developed also have to be incorporated. Then feeder roads also gave us some roads that were moved from feeder roads to highways. We have taken them into our network. Then we also need to give them numberings into the network. Now, the way forward is that we need to have another look at government's commitment to funding of maintenance projects. Then what I'm saying is that we can achieve 70% good, 20% fair, and 10% poor. In GH's strategic management, strategic plan for 2037. We have a strategic plan to achieve this, and we can also do that through a scientific means, selection of roads for construction. If you can use and optimize the use of the PMMP, that will help us, because you cannot have this goal without using any scientific means of selecting roads for construction. Thus, the PMMP becomes crucial in its in our achievement to achieving this strategic goal. Thank you, sir.